question number 11,
they have given us sigma k equals to 1 to 100 sine inverse x suffix k equals to 50 pi. Now, sigma of this thing is what? Sine inverse x1 plus sine inverse x2 plus sine inverse x3 plus dot 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 sine inverse x suffix 100
equals to 50 pi. Now we all know that the maximum value of sine inverse x is pi by 2 and the minimum value is minus pi by 2. Now when you have added 100 sine inverse x and the value is coming to 100 into pi by 2, that is 50 pi. So this is only possible when each of them are equals to pi by 2. Is always pi by 2. Therefore, it is only possible when each of them are equals to pi by 2.
So that implies x1 equals to x2 equals to x3 equals to x suffix 100 equals to 1. Now they have been said to find the value of sigma
all x k cube will give you nothing but 1. So it is basically 1 plus 2 plus 3 plus till 100. Have you understood this? These values are coming because of this k, not because of this. Because x k whole cube, all values will be 1 when k is from 1 to 100. Therefore, the final answer will be 1 plus 2 plus 3 plus dot 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 100. Add it up. What we are going to get? N into n plus 1 divided by 2. So that gives you what? Which is nothing but your 5050. Is it clear? Therefore, our option A is correct. For question number 11, option A is correct. In question number 12, they have given us
tan inverse A equals to cot inverse 2 plus n into n plus 1 divided by 2.
Is it clear? Now,
after simplifying, we are getting cot inverse 4 plus n into n plus 1 divided by 2. Now, cot inverse this thing equals to tan inverse 2 by 4 plus n into n plus 1.
let me divide both numerator and denominator by n into n plus 1. So we are going to get
which can be written as what?
tan inverse. You see in the numerator 2 by n into n plus 1, I am manipulating it like this. Is it clear? And in the denominator we are getting the same thing. So we are having this. So this can be written as what? It's tan inverse 2 by n minus tan inverse 2 by n plus 1. Is it clear? So your tan inverse A is nothing but tan inverse 2 by n minus tan inverse 2 by n plus 1. But listen it carefully. In the question they have given us sigma over here. I have not taken sigma yet. Okay, sigma is actually there. They have said tan inverse A is sigma of this. Okay, now I am taking sigma over here at the end. Okay, and your sigma starts from n from 1 till infinity. Is it clear? Now, in place of n, if I put 1, 2, 3, 4 till n, think about till n. I'm not going till infinity. What I'm doing here is limit n tends to infinity. I'm expanding this thing till n, and then I'm writing limit n tends to infinity. So what we are going to get here? In this case, we are going to get,
in place of n, if we put 1, for the first case we are getting tan inverse 2 minus tan inverse 1. And if in place of n, if we put n equals to 2, we are getting tan inverse 1 minus tan inverse 2 by 3. And in place of n, if we put 3, we are getting tan inverse 2 by 3 minus tan inverse half. And this thing goes on. And when we reach till n terms, the n term will be tan inverse 2 by n minus tan inverse 2 by n plus 1.
is it clear?
Now, if you observe, you will find that
Your this term goes off, this term goes off. So automatically this and the previous term will go off. Is it clear? We are left with limit n approaches to infinity, tan inverse 2 minus tan inverse 2 by n plus 1. Is it clear? Now limit n tends to infinity. This is 0. So it is only your tan inverse 2. Is it clear? N tends to infinity means 2 by n plus 1 is tending towards 0. So tan inverse 0 is nothing but 0. So we are getting tan inverse 2. So what we got actually is tan inverse A, nothing but tan inverse 2. That implies A is nothing but 2. Have you understood this problem? Therefore, my option B is correct. Is it clear? Therefore, option B is correct for question number 12. In question number 13, they have asked us
to find out the domain of the function and to define the function, box of x minus 1 should lie between minus 1 and 1.
Is it clear to all of you?
That implies box x is lying between 0 and 2. That implies x belongs to close 0, open 3.
Is it clear? Therefore, the required domain is x belongs to 0 to 3, 3 open, 0 closed. Therefore, my option for question number 13 is B. Question number 13 is B. Is it clear to all of you? In question number 14, they have given us the determinant It's a pretty simple sum. They have asked you to check whether this determinant is independent of alpha, beta, or neither alpha nor beta, or both alpha or beta. So to find out whether the value of this determinant is independent of alpha or beta or not alpha or beta, whatever, we have to expand this determinant, right? So I am just simply expanding this determinant. What we are going to get with respect to the first row, I am expanding. So we are getting sin alpha cos beta plus cos alpha sin beta plus cos 2 beta sin square alpha plus cos square alpha, which will give you 1. Now we are getting cos alpha cos beta minus sin alpha sin beta will give you cos alpha plus beta. So it is nothing but cos square alpha plus beta Sine alpha cos beta plus cos alpha sine beta will give you sine alpha plus beta, which will give you sine square alpha plus beta in this case, plus cos 2 beta. This is nothing but your 1 plus cos 2 beta, which gives you what? 2 cos square beta. Is it clear? So it is independent of alpha, because in the final answer there is no alpha. Therefore this determinant is, the value of this determinant is independent of alpha. Thus your option A is correct. So for question number 14, your option A is correct. In question number 15, they have given us
to evaluate.
So for this one we are doing 1 by root 2, I am replacing it by cos pi by 4 minus again sine pi by 4 sine 9 pi by 10. So we are getting here it as cos A cos B minus sin A sin B gives you cos A plus B. So pi by 4 plus 9 pi by 10. So if I take the LCM, if we simplify, we are going to get cos inverse cos 23 pi by 20. We all know that cos inverse x always lies between 0 and pi. Therefore, we cannot write this answer as 23 pi by 20 because this is more than pi, isn't it? So we cannot write this answer. So what will happen in this case? So what I'm trying to do is, I'm trying to reducing this value such that it falls between 0 and pi. So for that, what I'm doing is, I'm just doing 2 pi minus is it clear? 2 pi minus 17 pi divided by 20. So what we are getting? Cos inverse cos 17 pi by 20. Now you see 17 pi by 20 falls very much between 0 and pi. Is it clear? So 17 pi by 20 falls between 0 and pi. Therefore my answer will be simply 17 pi by 20 in this case. Is it clear? Therefore the option for question number 15, the right option will be nothing but your option D. Is it clear to all of you? So the answer of this question is your 17 pi by 20, which is nothing but your option D. Have you understood this problem clearly? In question number 16, they have given if x equals to 2 to the power x plus 2 to the power minus x divided by 2, and we have to find out the value of f of x plus y into f of x minus y. Is it clear? Now, what is my f of x plus y? It is 2 to the power x plus y plus 2 to the power minus x minus y divided by 2. And what about your f of x minus y? It is 2 to the power x minus y plus 2 to the power minus x plus y divided by 2. Now if I multiply this two, f of x plus y into f of x minus y, we are going to get 1 by 4 Is it okay? Now, let me just normal multiply these two terms. So what we are getting? 2 to the power 2x Is it okay? So it is nothing but your 1 by 4 2 to the power 2x plus 2 to the power minus 2x plus 2 to the power 2y plus 2 to the power minus 2y. So let me just take half inside. So we are getting half outside. 2 to the power 2x, 2 to the power minus 2x divided by 2 plus 2 to the power 2y plus 2 to the power minus 2y divided by 2 again. This is nothing but your f of 2x. This is f of 2x, and the second part is nothing but your f of 2y. Is it clear? Therefore, the value of fx plus y into f of x minus y is nothing but half f of 2x plus f of 2y, and the option which is correct is option B. Therefore, option B is correct for question number 16. Have you understood this? In question number 17, the definition of the function given as f is from minus half to half to minus pi by 2 pi by 2. Now we have been given fx is sine inverse 3x minus 4 x is cube, right? Now let us say x equals to sine theta. So we are getting fx as sine inverse sine 3 theta. Now, as they have said from the definition, we can say that x belongs to minus half to half implies theta belongs to minus pi by 6 to pi by 6. Have you understood this? X is nothing but sine theta. X is lying from minus half to half. Therefore, your theta will lie between minus pi by 6 to pi by 6. So that implies 3 theta belongs to minus pi by 2 to pi by 2. If it is so, then sine inverse sine 3 theta can be written as simply 3 theta. So 3 sine inverse x in this case. Is it clear? Now if I draw the graph, of 3 sine inverse x, how it will look like? Is it clear? Now we have been restricted from, you see, your 3 theta, 3 sine inverse x, x is lying from minus half to half. This is half. This is minus half. Is it clear? Now for this, for half and minus half, 3 sine inverse x will lie between pi by 2 and minus pi by 2. Is it clear? Have you understood this? 3 theta will lie, 3 sine inverse x, which is nothing but your given function, will lie between minus pi by 2 to pi by 2. Now from this graph itself, you can clearly see that this function is 1, 1 as well as onto. Is it clear? The function is 1, 1 as well as onto in the given codomain, because here the codomain becomes its range. Therefore, it is an onto function. And as well as you can see that this function is also a 1, 1 function. Can you find it out? How to check whether a function is a 1, 1 or not? By using in graphical method also, you know this graph. So how to do it? What is the formula? What is the technique? The technique is for 1 y, you must get 1x. That is what is called this all we have done in functions. That is what called your horizontal line test. For this one, for any y you choose, you are always going to get only 1x. So horizontal test fulfills this condition. Therefore, it is a 1, 1 function as well as it is an onto function. Onto function because your codomain becomes your range. Therefore, A is correct for question number 17. Option A is correct for question number 17. Have you understood this? In question number 18, they have given A and B
are two square matrices.
same order, and A transpose is your identity matrix. Then we have to find out A transpose B A whole to the power 10 is what, and 4 options are given, right? Now for this, let us start the sum with A transpose B A whole square is what? So this can be written as, again they have given you A transpose is I, so this is IBA, which gives you again A transpose BB, because I into B will give you B only, so B square A. Is it clear? So A transpose BA whole square is coming to A transpose B square A. Now let us check. A transpose BA whole cube is what? So which can be written as A transpose B square A transpose B A. Have you understood? I have replaced A transpose B A whole square as A transpose B square A. Exactly what we got right now. Now if I open the bracket, again AAT will be replaced by the identity matrix I. So we are getting AT B square IB A. So again we are getting it as IB will give you B, B square into B will give you B cube A. Now observe carefully. When it was A transpose B A whole square, we are getting A transpose B square A. When A transpose B A whole cube, in that case we are getting A transpose B cube A. Therefore, we can say that A transpose B A whole to the power 10 will give you A transpose B to the power 10 A. Is it clear? Therefore, our option B is correct for question number 18. Your option B is correct for question number 18. Have you understood this problem clearly, everybody? In this question number 19, they have given us that AN and BN are two matrices of order 3. It's a square matrix, they have said. And they have said that, and they have defined the matrices as AN is Aij, where Aij is 2i plus j divided by 3 to the power 2n. Similarly, Bn is a matrix of elements Bij, where Bij is 3i minus j divided by 2 to the power 2n. And they have said that I and j are all lying between 1 to 3. Naturally, because it's a third order matrices, so your Ij will take the combination of 1, 2 and 3. Now, before starting the sum, you must remember two things. I hope you know this. Trace of any matrix A multiplied with the scalar k will give you nothing but k times trace of A. Is it clear? That is, trace of any matrix multiplied with a scalar k will come out and it will become k times trace A. And number 2, we have to remember, trace of A plus B is nothing but your trace of A plus trace of B. Okay, so these are the two formulae that we have already learned in our matrix chapter. Now, what is my A1? A1 will be the elements Aij of that matrix, where Aij will be 1 by 3 squared 2i plus j. A2 will be where Aij is 1 by 3 to the power 4 2i plus j. A3 will be similarly the elements Aij, where Aij is 3 to the power 6 2i plus j, and this thing goes on, and your An will be the matrix of elements Aij, where Aij is 1 by 3 to the power 2n 2i plus j. Clear? Now they have said that your L is nothing but limit n tends to infinity, trace of 3a1 3 square a2 3 cube a3, and this thing goes on, a3, and this thing goes on 3 to the power n an. Okay, now this can be written as what? Limit n tends to infinity 3 times trace a1 plus 3 square trace a2 3 cube trace a3, this thing goes on 3 to the power n trace an. Is it clear? Now what about your trace of a1? Look at carefully. What is trace a1? Trace a1 will be your 1 by 3 square. Trace a1 means we are adding the diagonal elements, that is we have to find out a11 a22 and a33, and if we add it up we always get the trace of that matrix. So in this case what will happen? If I take I as 1, j as 1 for a1, what we are going to get? Here 3, then if I put 2 it's 6, and if I put 3 it is 9. So what it is coming? It is coming like 1 by 3 square into 18. Is it clear? Similarly you will get trace of a2 as, look at carefully, this part will remain same. For all the cases this part will remain same, only this part will change, right? So for trace a2 it will be 1 by 3 to the power 4, again 18. Trace a3 will be 1 by 3 to the power 6, again 18, and this thing goes on. Your trace an will be 1 by 3 to the power 2n, again this is 18, right? Now if I put all those values here, so we are going to get, and if I take 18 common, we are going to get something like this. Is it clear? It's in. Is it clear now? Okay, now you observe that this is a GP series whose first term is 1/3 and common ratio is also 1/3. So if I apply the formula of summation of GP series, what we are going to get? (18) is outside. So what we are getting here? Limit n tends to infinity. In this case what we are getting, this is basically 2/3, so it will be 3 by 2. Now observe it, if n tends to infinity, 1 by 3 to the power n is tending towards 0. So what we are getting here, this will get cancelled, so we are getting here as 9. Is it clear? Therefore we got our L as 9. Okay, now let me rub this one. Now for the matrix Bn, your B1 is the matrix of elements Bij, Bij, where Bij is 3i minus j divided by 2 square. Is it clear? In place of n, I am writing 1. Now what about your B2? It will be 3i minus j divided by 2 to the power 4. Similarly, B3 will be 2 to the power 6, and this thing goes on. So Bn will be matrices of elements Bij, where Bij is it clear? Now they have given us that your m is limit n approaches to infinity 2b1, 2 square b2, 2 cube b3, this thing goes on, and 2 to the power n, the last term is 2 to the power n, bn. So now I will not expand it elaborately, because just now we have done for finding out the value of n, L. So you can do here in a similar way. So what we are getting, I'm sorry, here trace is there, right? Trace is there. Okay. So this can be written as, I'm doing little fast so you will understand. Now see, what is your trace of B1? Your trace of B1 will be 1 by 2 square will be there, and inside it will be 3 into 1 minus 1. That will give you 2 plus, when I put I as 2 and J as 2, so we are going to get 4. And when we put I as 3, J as 3, so we are going to get 6, right? So this 12 will be common for every case. 12 will be common for every case. That is what I'm not writing. I will take it common. So it will be only 2 into 1 by 2 square. 1 by 2 square. Okay. Plus, for the second one, it will be 2 square into 1 by 2 to the power 4. Then it will be 2 cube into 1 by 2 to the power 6. Plus this thing goes on, and the last one will be 2 to the power n into 1 by 2 to the power 2n, and outside I have taken 12 common. Is it clear? So what we are getting? It's half, 1 by 2 square, 1 by 2 cube. So again, it is a GP series whose first term is half and the common ratio is half again, right? So we are getting what? Applying the formula, we are getting into 12. So what we are getting basically here is limit n approaches to infinity 1 minus 1 by 2 to the power n into 12. As n is approaching towards infinity, 1 by 2 to the power n will approach towards 0. Therefore, we are getting the value as 12. Therefore, m is nothing but 12. Is it clear to all of you? Now they have asked us to find out the value of L plus m. L plus m will be nothing but 9 plus 12, which gives you 21. Absolutely clear now? Therefore, the option B is correct for question number 19. Option B is correct for question number 19. Is it clear to all of you? Have you understood this sum properly? Question number 20 says, in a third order determinant, each element of first column consists of sum of 2 terms, each element of the second column consists of sum of 3 terms, and each element of the third column consists of sum of 4 terms. Then it can be decomposed into n determinants, where n is the value, has a value, and the 4 options are given to us. Now, first of all, we must remember that if a determinant, if the first row consists of m elements, sum of m elements, the second row, it's not 0, these are all elements. The second row consists of sum of n elements, and the third row consists of sum of say p elements. Then if you decompose this determinant, we are going to get m into n into p number of determinants. Have you understood this? Now, in this question, they have said that the first column consists of the sum of two elements. Each element of the second column consists three elements. Third column consists of the sum of four elements. Okay? Therefore, if you decompose this determinant, we are going to get total number of determinants as 2 into 3 into 4, which is nothing but 24. So 24 number of determinants we will get when determinants is decomposed. Is it clear? Therefore, our option D is correct for question number 20. For question number 20, the answer is D. Is it clear to all of you?